So let's take a look now at some intersections of conics, right? And just looking at these examples, seeing what we can do for these types of problems, and some of the best techniques to. Okay, so for this first problem here, let's take a look. Okay, so we're going to find the intersections for the given conic sections, sketch the conics to support your answer. Okay, so if I'm looking at these two, first of all, I know they're both going to be circles. How do I know that? I have them both squared, and they're being added together there. So since they're added and they're both squared, it has to be. If they were, one was positive, one was negative, that would tell me it's a hyperbola. If I had one with a coefficient other than, they differ in coefficients, that'd be an ellipse, right? So two circles here for myself. Okay. To solve these, right, I think that the best way in this case is to just subtract. Let's see. I was thinking about subtracting the top from the bottom, but that would get rid of the x squared and the y squared, but then we'd have an x and a y left over. So yeah, I could do that. That would work just fine. So let me try that. Okay. So these are going to cancel. So I'll have negative 4y plus 2x equals negative 4. Okay. At this point, I could then say that x equaled 4y plus 4 over 2. So x equaled 2y plus 2. Okay, for myself. So I know that. So I can take this then and plug it into one of those two equations I had at the beginning. Sorry that it's a little fuzzy. Let me just see if I can get this to work a little better. Okay. Right, so I can then take this and plug it into one of the two equations. And which one I choose to plug it into really depends on ease. If I plug it into the top one, the x is only in one spot. But if I plug in the bottom, it's in two different spots. So I'm going to have more terms to work with. So I'm going to choose the top one. Checking my work here, see if I made any mistakes. Something's off here. Oh, that's a 5. Okay, a 5y squared there, and then something's off here. I think I'm just looking back at my work. Right. Okay. Pause 1 sec. Oh, I found my mistake. There's a minus up here. Sorry about that. Okay, there's a minus there, so that's a minus there. Okay, that's a minus here. Okay, which makes this a minus, which makes that a minus 12. Okay. Now at this point, we prefer if it factor, that's going to make the numbers easier. If not, we use the quadratic formula. Let me see if this is going to factor here. Yeah, so negative 2 for both of those. So middle terms are going to match up. Okay, so my y values are going to be 2, and then the other option is going to be 2/5. So I have my two y values there. Okay, if I where can I plug them in? I can plug them in anywhere, but it's to plug it in right here, because just for ease, if I plug it in there, that's going to give me that if the y is 2, right? If y is 2, then the x is 2 as well. So I get 2. 2 is one of the points. If I plug in 2/5 right here, I get 4/5 minus 10/5, right? So 4/5 minus 10/5 is negative 6/5. So I get my second point. So there's two intersection points for this circle. If I think about the graphs of these circles here, right? This first equation, right, is if I were to complete the square, so it has a center at 0, 2, with a radius of 2. this other circle here, if I complete the square, x minus 1 squared plus y squared equals 4, and I'm going to need to add 1 to that, I think. Yep, so it's going to be a 5 right there, okay, for ourselves. And so that means that the center is going to be at 1, 0, and the radius is going to be root 5, which is a little bit more than 2, so it's going to be a little bit more than 2. 1, 2, a little bit more than 2, right? 1, 2, a little bit more than 2. Okay, so my circle is going to be something like this. And we can see our 2 intersections points right there and there. Okay. The goal of this is not to be perfect and say that this is definitely a 2, 2, and this is at negative 6, negative 6/5, 2/5. It's just to say, hey, this gives us the correct number of intersections. We have 2 intersections. They both look like they're going to be in the ballpark there, right? So that tells us that's going to be reasonable point that we have. Okay. So you can see that there's 2 solutions. If the circle was centered way down here, it's possible that they didn't intersect and we'd have no solutions for it. Or if they, if this radius were really large, it would totally encompass the other circle. There could be no solutions for it, and that's fine. I mean, when you're doing these, you could have anywhere from 0 solutions to 4 solutions. And I'm trying to think if you can have more than 4. I don't think you can have more than 4 for them. All right, so just look for that whenever you're doing these examples here. Okay. So let's take a look at B now. Right, and now you've kind of seen one. You could just like try them all on your own. You can watch what I do for B. Okay. Actually, I think I'm looking at B, and I think you guys can do that one on your own. So I'm gonna let you try that one. Okay, so let's look at C here, and I'm just going to quick peek at the solution techniques. Okay, so I'm going to let you guys do C as well, and the reason I'm going to let you do C is because when it's a parabola here, both of these, they have parabolas in them, and when it's a parabola, you can solve for one of the variables, kind of like when I got to this point here and plug it into the other, right? So B and C, right, it's kind of the same as A, it's just you're able to get that X value and plug it in, okay? So let's look at an example like D then instead, right, which is going to have something, which is going to have a little bit more craziness to it, to the work. Okay. So, how am I going to solve this one? Let's take a look. Okay, so for these ones, I don't really see that elimination is going to work so well to really get rid of these square terms like I had in the other ones. So when that elimination is not going to work for you, right? Your best bet is to put them into your graphable form, basically. Getting yourself putting it into general form for yourself. Okay, so if I'm looking at the first one there, I'm going to have 9x squared plus 6x plus something, right? Minus y squared minus 10y plus something. Okay, and I'm going to move, let me just make sure I did that right. Okay, and I'll move that 55 to the other side there. Okay, now if I complete my squares, okay, that's going to be a 9, and that's going to be because it's going to be x plus 3 squared. And this one is going to be a minus 5, which is going to make that 25, which means that I'm adding 81 from this one, and I'm subtracting 25 from the other one. So overall, that conveniently gives me 1 right here. Okay, so I get to that point. And that's the first equation. If I look at that second equation there, and I was going to do the same thing, I'd have x squared plus 2x plus something, minus, take out the negative 9. Okay, because I'm taking out the negative, that's why this is becoming a plus there, so be careful of that. Okay. When I complete the square, so it's a 9, that's a 1, so here I'm adding 1 to it, here I'm subtracting 81, so the side equals 0. Oh, so conveniently, this one is degenerate conic, right, for ourselves. And that's convenient. It is convenient because then I can actually solve for x or y here, right? Because I know that x plus 1 squared equals 9y plus 3 squared. Okay, so a degenerate conic is not a problem. It's actually better for these. It's easier for these. Okay, ideally these, you know, it'd be even easier if one of these groups matched up. Like if that group was exactly the same as that, then I could just say, oh, let me just do substitution. And so you'd like to have that happen, that one of those two groups match up. And that's one of the things that conveniently will happen on these, just to make them solvable. Right? Very hard to solve them if those don't match up. Okay, but if they don't match up, maybe you have something where it's degenerate and you can do it. Right? So for this one, we know that x plus 1 equals plus or minus 3. Okay, because take the square root of both sides. So we know that x is that. Okay, and you know, it's kind of, I solve for x because I don't want to have a fraction in it, but I have the x value, and now I can plug this in to this right here, or I could go back here and plug it in right here, and it's really up to you where you want to plug it in. Do you want to plug it in here, right, where there's only one x value, or up there? So I'm going to choose to plug it in right here. Okay, and I mean, is that better? I don't know, than plugging the other one. It's hard to tell. It was going to be, no matter what, it was going to be a little bit brutal for the math. Okay, so I'm going to do two cases. I'm going to do the positive case and the negative case. So the positive case would be 9 times 3y. Let's see, that's going to be 9 minus 1 is 8 plus 11. Okay, and so that's going to give me then 9y plus, that's 66y plus 121 times 9 minus 66 times 9 is going to be 594. Right. Okay, yep, it's checked. 9 times 121 is going to be 1089. Let me just check that. Okay. That's y squared. Okay, so I get 80 y squared, right, plus 604y, right, and then I move these around, so that's going to be, right, subtract 26 from this. Okay, so we get that. And at this point, I'm just going to put that into my quadratic formula. Right? Oops, I'm sorry, I got one off the bottom of the screen. I'm going to put it into my quadratic formula to figure out where the y values are going to be. Okay, and you can put that in quadratic formula. Right? Okay. I'm also going to do the negative case. If I do the negative, now I have to go do the negative case. That's why I use the negative here, and I just redo this all, but with this being a negative y. So this one is going to have 4 solutions, and they're going to be four pretty nasty solutions. And that's, as I said, that can happen here as we do these. Okay, so it's really just a technique in creatively solving systems as you go through these and doing the best you can. Okay.